Okay, so we're going to have a look at the following question here. We're going to find the limit as n tends to infinity of the following series here. Okay, so it can be quite daunting when they ask you to find the limit of a series like this, but I would generally think about using the sandwich theorem, and I'm going to just work you through this example, and we're going to see it's going to be using the sandwich theorem. Okay, just forget about this little bit of a typo because I screenshot it off my notes, which you can obtain from my Google Drive, and I've attached a link to that in the description of the video. Okay, so we can observe that the general term of this series is 1 over n squared plus this term k. Okay, and we know that k just varies between 1 and n. Okay, so just a general term for this series is 1 over n squared plus something, and that something, as we can see here, varies between 1 and it goes all the way up to n. Okay, so what we can do now is we can bound this general term. Okay, so I know that the lowest term in this series is this last one here. Okay, this last one here is the lowest term. Okay, how do I know that? Because let's compare the first term and the last term. Okay, so the first term is 1 over n squared plus 1. Okay, and the last term is 1 over n squared plus n. Okay, assuming n is positive, and we can in these questions, we have a bigger number on the denominator here. N squared plus n is clearly larger than n squared plus 1. Okay, and due to the fact that we know n is increasing as well. So 1 over a big number is going to be a smaller number than 1 over a smaller number. Okay, so we know 1 over n squared plus k. We can also mention here that n is greater than or equal to 1, which we can with these questions again. So we know this is definitely going to be bigger than or equal to 1 over n squared plus n. Okay, and how many terms are there in this sequence? Well, there's 1, 2, blah 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 blah, all the way up to n. So there's n lots of this term here, hence why we multiply by n. Okay, conversely, we also know that this general term here is always going to be smaller than or equal to the biggest term in this sequence, okay, which is the first term, 1 over n squared plus 1. And we need to remember here that this is a general term for the whole series. Okay, so again, we need to multiply this by n, because it's kind of like thinking about there's n lots of the largest term. This whole series, this whole thing, I could substitute this, literally this line, I could substitute it into here. So I need to multiply this by n to show that it's kind of n lots of the largest term. Okay, and what I can do now is I can simply just take the limit of the left and right hand sides of this inequality. Okay, so I can just divide by the highest power in the denominator, so divide by n squared, get 1 over n over the square root of 1 plus 1 over n, smaller than or equal to, and just represent this by xn. Okay, and this is smaller than or equal to, again, dividing by the n squared, 1 over n square root of 1 plus 1 over n squared. Okay, now I can evaluate the limit as n tends to infinity of both of these expressions, and I can see that the limit as n tends to infinity of this expression is 0, and the limit as n tends to infinity again, 1 over n, 0, 1 over n squared, 0, 0 over 1 is just 0. So we can conclude by the sandwich theorem that xn tends to 0 as n tends to infinity, because it's bounded by two sequences which also tend to 0. Okay, thanks very much for watching, and I hope this helped. You can find this example along with all of my other examples in my notes, which are attached in my Google Drive, which you can find in the description of this video. Thanks very much.